Hi, I'm going to present you a demo, a prototype of the CM4 board case, just because the final version will be done in a later time and I will present you this in a separate video. But first, in the beginning, I would like to talk about some prerequisites and that are required actually, and this is my experience with building this case. Why I'm doing it? Okay, so in the beginning, it was over a year ago, I have seen this ultimate Raspberry Pi computer build water cooled CM4 with NVMe SSD. So, okay, Michael have everything in the description. Much more. And you can see there is a list of things you need to buy. First of all, you need to buy a Raspberry Pi CM4 compute model. I don't have a Lite, I have a full one. I have 8 GB with Wi-Fi, Bluetooth, and 32 GB memory installed on it. EEP, if I remember correctly. And you can see currently it's out of stock on most stores here. We will try to no products for query, but we can look for the CM4 compute module here in the internet, and for example this one, and here we have 32 variants of this, and you can see a lot of this, and mostly you have to choose the version you want. I have 8 GB of RAM. I have version this, no, 32 GB of eMMC flash memory, and I have a Bluetooth and a wireless. So I have the best model, the strongest one. And we are going back to the list. So the whole project is actually expensive. Michael do not sell it this case, but he's selling on Etsy the project. Project is divided into two parts, and inside of this here you have 4 holders. They need to be printed on a 3D printer, and the rest is just acrylic sheets, the white one. And few important information. The first one, and there are 2 types of white color: shiny white, that is more expensive, and milk white, that is a little bit dimmed, but it looks like I don't know how to explain it exactly. Maybe not so nice like this one, but also interesting. And I'm going to present in a moment what I actually did with my prototype. So we are going back to camera, and here we go, and this is it. So you can see the difference, and I will try to turn it on and remove it, and you can see the difference, because this one is a milk white and this one is a white, and you can see the difference in color, a little bit different, right? And that's okay. Michael, one thing, those holes should be moved a little bit closer to the side panel. Why? I'm going to explain this in a moment. I will put it like that, and here we go. Here we have something that I can grant you, and if you will put this like that, you have to be very careful. You need to exactly pull a little bit the board. So right, it cannot be on the side panel, but a little bit higher. So I will have to figure it out how to make it work to put it a little bit higher. So I will try to do that. One more thing I'm going to explain in a moment. I will have to redesign the whole project. I mean this side panel, and because I need two additional holes here, and I'm going to explain in a moment why I need it. Okay, so you can see the whole project here, and Michael is talking about this. Yeah, and you can watch his video, and I really recommend it. And in the meantime, I will try to present you why I need two additional holes in the side panel. Okay, so what I want to do, you can see I bought this, Michael, acrylic cylindrical water tank. I mean, there is a coolant inside of it, and inside of it there is a, you can see the water pump, the vertical one, not the horizontal one, because there are two versions of this pump, and you need to first of all find out that you need the vertical one. So the inside there is a, to present it on the screen, but you need to the pipe is going up here, so it's the small pipe is up, not horizontal but vertical. Okay, so this is the most important thing that you need to understand. And all those things have threads here. There is a thread here, and you can easily remove this, and also this. All of these have threads, so you can remove it. What I had to do, I had to drill a hole inside of it and to put the cable from the water pump through the I don't know how to explain this, how to call it. Say lead, maybe it can be lead. So I drilled a hole, and what then I did, I used the glue, and you can see it's glued, so to avoid the coolant will just flow through the hole. And I had to put then this at the end. So this is a connector, if I remember correctly, a DuPont connector set. This is it. Yeah, this one, you can see. And what I needed to do, connector crimpers, this one. Yeah, and this is a tool that you need to put everything together to be able to mount this crimp actually on the, to put this on the cable. So this is the pin connector. This is it. Thanks this you will be able to do that. And that was something that I had to learn, and I was watching videos on YouTube how to use a crimping tool to be able to use this connector, this pin connector. Okay, and here we go. You can see the one pipe goes out from the, actually here, this one goes out from the tank, then it goes to the water block, and water block you can buy on Etsy from Michael too, because he's selling water blocks with thermal pad and bracket for a Raspberry Pi, not for a CM4 board. So for CM4 board, a bracket is a little bit different and smaller, and it's included in the project on Etsy. So you can buy the project of this case on Etsy from Michael too. And the pipe from water, the second pipe from water blocks goes to the radiator, and the pipe from radiator goes back to the tank. And okay, this is it. What's next? Next thing is quite easy. I had to buy these two, something like that. We have two, so you can easily put it on the tank like that, and that is why I need two holes on the side panel to be able to mount it to the side panel like that. And you have screws here, so you can use it. I'm going to present it in a moment. Give me, and in the package, yeah, we have something to, yeah, two with those small. I'm not removing it, this and this, so you have to use this to put it together and mount it on the side panel of the case. Lovely. What's next? Next thing is really important too, because this is the power adapter like this one. And if I remember, I need to find out, just give me a second. It's about 12 volts. Yeah, 12 volts, 3 amperes, and I need to log in to find out the, so if I remember, 5 millimeters length, and the diameter is 2.1, yeah, something like that. And I will try to provide the information, and it's 12 volts and 3 amperes, 36 watts, and yeah, this is the AC/DC adapter. So you need to use this, because if you want to use CM4 board, compute module, you need to power the fan, the Noctua fan, the PWM fan, and also the NVMe drive. At least 3 ampere is needed, or even 4 or 5 ampere probably. But this is something that you need to figure out. I bought 3 ampere, so I will try to make it work. Okay, then what's next? Next things is this actually, and you can try to understand why I'm not using a glue anymore, but methylene chloride. Just because, and also this glass syringe and a needle, a glass needle, no, a metal needle. Sorry. Where I have needle. Yeah, this one, like that. And because you need a very, very small amount, of this, of the methylene chloride, to glue everything actually, because if you are using something else like Weldon or super glue, well, I was using Weldon. Weldon is not so bad, but it's hard to get it, the proper Weldon version, and I will try to present it on the screen. Here you can see the super glue on the edge, and like that, and this is not a very nice, and I really don't like it. And also here, this is something that probably it will look better when I will use the chloride. Okay, so I'm going to use it and give you a clue. Is it better? I suppose it is, because the guy from the company and where I was cutting the parts in acrylic sheets, he guided me. He told me that methylene chloride is better to glue everything, and I'm going to use it. I already tested it on small part, and it's very good because you really need a small amount of this, and thanks using the glass syringe, it's much easier to apply everything on the surface. And that was something that I wanted to check. And yeah, and the one thing that is important, that it's not gluing, glue bonding, something like that. Glue bonding, yeah, it's not bonding all those pieces too quickly, but you have, I don't know, 2-3 minutes, maybe more, to make a small correction, so you can, if there is, you can move it one part amongst another, and you can, everything put together correctly. And after some time, the bonding is enough strong, and it's glued super hardly. So you can put methylene chloride. You can put a small amount of methylene chloride on the surface, and you have a time to make corrections, right? So this is something that is really good to know, that you can use it. And what's more, I'm trying to figure out the most important thing that in this project actually is that you need to a little bit redesign each time, because first of all, you need to make a prototype to be sure that everything is working together properly, and that is something very important, that it fits together, right, to make it work. And that is why I'm prototyping it. The whole project is really, really expensive because CM4 board, I'll try to figure out. Just give me a second. Look for CM4 board, how expensive it is in Poland. A moment. Yeah, it's 229 currently. Compute module. Here's this one. Currently, compute module. Try to figure out here. This one, it's about. Let's check this. Compute module 4. I'm not sure do they have it already. They have it, and the price was because it's unavailable. So the strongest module, this one, it's about 500. You can see over 500, and yeah, I bought it currently for 750 Polish. So expensive. So 220 and 750. So that is really, really, really expensive if you want to start with this. And after that, you have to figure out what to do with the rest, because when you want to buy it, and just because if you are only buying a CM4 board and computer module, it's 970. Yeah, so expensive. And the case, I don't know, 3D printing 4 pieces, about 100 to 150, maybe less, It depends on the company where you're printing it. And the rest, the acrylic parts, about between 150 to 100, or maybe less, maybe more. Hard to say. It depends on the needs, and I will try to find out how much I had to pay. Give me a second. I will need to find out, just because I was buying it over a year ago, and the prices were different. Currently, probably the price will be higher. Try to figure out. Give me a second. Yeah, the Crafters. This is the company in Lodz, Crafters PL. The price was about 130, something like that. Of course, I was prototyping it, so the price was higher because I ordered more than one project. I mean, they cut it one project for a Raspberry Pi. It was a modified project a little bit because I had to modify holes in the back panel for a Raspberry Pi, and I did it for a Raspberry Pi. I mounted a water cooling system on a Raspberry Pi, exactly the same that I was presenting earlier. But currently I'm using something like this. I'm going to present you in a moment. Currently I'm using this on a Raspberry Pi, and using this tower. It's a horizontal tower, ice tower cooler with RGB. I'm not using RGB fan. I just replace it with the black one. And I'm using also a Noctua fan, but not the PWM, but with 4 cables, but only a standard one with 3 cables, because I don't want to control. It's working all the time. And this is also working all the time. There is no control. You are not controlling the work and when it will turn on or off. So using 3 volts connections, both fans are working constantly 24 hours a day, and the temperature is about 34-35 degrees of Celsius. It's a median of this temperature, and it depends on the temperature in my compartment. So in winter I have about 30-31 degrees of Celsius on a CPU, and in summer currently I have about 34-35 degrees of Celsius, sometimes 36. It depends on the load. And yeah, so I'm using this, but I was using a water cooling system, and water cooling gave me results about 29 degrees of Celsius in summer and 27, 26 in winter. Okay, so crafters PL. So I suppose there is something. What is going on? Something. We'll try to. Like that. Crafters PL. Sorry. Yeah, this company is cutting acrylic parts, but not only. And I really recommend them. And I need to look for the company for CM printing module. Just give me a second and I will find it. Because I'm looking for the solution. Give me a second. I'm looking for not this one. give me a moment. I'm looking for the company. SMK3D. Yeah, this one. SMK3D. They are printing using 3D printers. They are printing models, and I really recommend them because each time when I need to print something, I'm calling them and I'm sending them project, and they are printing them project for me. So those two companies I was working with, and they helped me to make this case, and I was able to do that. Thanks to this, I was able to achieve my goal and create a prototype. So thank you very much, Michael. Just because I had to buy everything. So the CM4 board and computer module 970. The rest part, seriously, the price is crazy. Over 200 Polish zloty. All the parts, all the printings, all the cuttings, everything that when I make I added all the prices for every single part I had to buy for this project. So it's extremely expensive, almost 3,000 Polish zloty. So I will try to make a comparison. Just give me a second. It will be 3,000 PLN to USD, to American dollars. It's about 750 USD, and Audi, yeah, it's Australian dollar. It's 1,100 currently the price, and this is the price I had to pay for the whole project. So it's crazy. It's really crazy, but that is something that is worth to mention. That if you want to make it work, you have to be ready. If there is someone in Poland, I can do the case for you. I mean, maybe not the case. You will have to send the project to a company that will print it for you and will cut with the laser cutter in acrylic sheets the parts. But I can send you, I can sell you some parts on that, and then I will create a video how to make it work. Actually, Michael already presented it, but then he modified the project. So I'm going to record a new video about this, and I will present how to make it work using everything that I was presenting in this video. I will also provide you all in the description all the necessary things you can buy on Amazon, AliExpress, on Allegro in Poland, because we have Allegro. It's and Allegro was first in Poland, so and then was Amazon and eBay. So we are buying also here, and you can buy some pieces already in different companies. That is normal. I'm not advertising it because no one is paying me for the advertisement. I just recommend them because some pieces are available on Amazon, some on eBay, some on AliExpress, some on Allegro, some on Etsy, like the project, and there are some other companies that you can look for in the internet, and you can find the cheapest one that will cut the part and will print the part for you, right? So it depends on you. That I recommend not to buy a laser cutter or 3D printer, or if you already have it, then yeah, but this is really also expensive. Actually fun and hobby, but I think that it's worth to make it work and to work with this in the future and present it in home to your colleagues at work, because this hobby gave me a lot of knowledge. First of all, I had to learn microelectronics because I had to learn about MOSFETs and about relays. Of course, I had a basic knowledge from the university about it, but I had to learn more how to work with this, because if you want to control fan, if you want to control a water pump using a Raspberry Pi, not a CM4 board, then you need to use relays or MOSFET. I recommend relays because I was testing both solutions, and relays were better. Just you can buy a module with 2 relays on it, and I think I have it, but I'm not sure. I don't have it currently here. I will present it later one day in a separate video how it looks like, and it's easier to connect the module with 2 relays to a Raspberry Pi through the GPU and control the speed of the fan and the speed of the water pump. And also you can write a program in Python to make it work the way that if the temperature is below some threshold, the water pump and the fan turns off, and when the temperature is above some threshold, I don't know, 40 degrees or 45 or 50 degrees of Celsius, then the water pump and fan turn on, and they are working and they're cooling the whole Raspberry. And in CM4 board, you have already some ports on the board, so you can just connect it and it will work for you. So you don't have to use relays or MOSFETs. But because in the beginning I had a Raspberry Pi, so I had to learn it. Microelectronics, yes, that was something that was obvious. And also I learned how to write code in Python to control devices that are connected to the Raspberry Pi. So this was something also cool for me, and I had to learn a lot about Raspberry Pi. And finally, what I decided to do, I have 3 things that I want to make it work. The first one I already realized, and I recorded a video about this, and you can watch it on my website. It's network UPS tool, and I connected it and controlling it with Raspberry. Then I installed a Home Assistant supervised on a Raspberry and on a SSD drive. And I'm not using a card, but I'm using a SSD drive, and you can see in the internet, look for in the internet how to make it work, and to boot the system from the SSD drive and to have everything on an SSD drive. Why? Just because the Home Assistant supervisor, actually Home Assistant, it writes and reads a lot from a disk. So SD card is not a solution, and it will just kill the SD card after some time, after a year or 2 or 3, but sooner or later it will kill it. And besides, SD card is slower, so SSD drive is much faster. So you can buy some good SSD drive and connect it to the Raspberry Pi through the USB port, and it will work. And it's working constantly through the USB 3.0 port, and everything is working as expected. And on the Home Assistant, you can install everything. You can install HACS, and you can install then additional add-ons like, I don't know, for example, P-hole or AdGuard Home. It's just a DNS, so that you can use to control the traffic, to cut the unwanted traffic from the tracking systems. And I'm currently using AdGuard Home, and it cuts about 20-25% of the traffic. So this is something that is worth to mention. And you can install a lot of things on Home Assistant, and you can automate your home if you wish. So this is the one thing that you can use Raspberry Pi for, but you can use a Raspberry Pi even for watering your flowers. Also, it's working, and I've seen such project. But currently, I would like to use CM4 for two things. First one is Proxmox, and I already have a Proxmox on Esprimo Q920, but I would like to move it to the CM4 board. And on the Esprimo, I will try to install Kubernetes, and also on CM4 board, I would like to use Minikube. I don't remember. It's a Kubernetes for Raspberry Pi. But so, and it will work. I know that it will work because I've seen projects with this, and I'm going to use it. And I would like to have two Kubernetes in the future, and Proxmox and some NAS solution, backup solution, etc., etc. So that will be a fun, because I don't want to use actually a standard computer, standard PCs, but instead of I would like to use Raspberry Pi. It's really expensive now just because it was cheaper 2-3 years ago, but I don't know. Will it be cheap? I doubt. Will price drop? Probably yes. How much? I'm not sure. I don't know that. But I will wait. Just maybe in 2 or 3 years, I think that prices should drop a little bit, and it should be a little bit cheaper. However, you need to remember that currently there are other microcontrollers. Not only Raspberry Pi is on the market, so it's good to watch some videos on YouTube and to find out what to buy and how to use. However, I think that the Raspberry Pi community is big enough, and there are many projects that you can actually read and use in your home. So that's the reason. Anyway, what I would like to say at the end, I would like to wish you good luck, and I hope that someone will decide to contact me or Michael, or even both of us, and we'll try to make the same case in home, and we'll record a video about it, because this case is really, really interesting, and water cooling maybe an overkill, but this is something that is worth to learn to use. And I think, Michael, that it's a good idea that you can use the acrylic cylindric water tank that I was presenting on the video previously earlier, and you can try to make it work with this, because to be honest, your solution with water tank, very do it yourself. Something really incredible when I saw you and you were doing it. Oh god damn, that is he seriously doing it? Yeah. But this acrylic, I will give you a link if you will contact me via email, and you will be able to buy it and test it. I think this solution is quite good, and it's worth to mention and worth to check when it suits you, actually, because I think that it's interesting, and to be honest, both more safe, I don't know, but it looks better in my opinion. Your tank is smaller, this one is bigger one, but there was no other choice to, because the diameter must be prepared to put the water pump inside of this acrylic tank. But I was buying a lot of tanks, actually, because I have smaller one that was, and the diameter was correct, but the tank was too short, and I had to buy a higher one. This one is longer, So I bought a cylinder that is half size of this, the same diameter, but half size. Was too small. So this is how it looks like, and I think that I will try to. This is the pipe inside of it, and you can see it. Send it green. You can see it. This is the pump, the black one. Try to move the camera. Okay. We go. We have the camera, and you can see the pump inside of it. Lovely. And if I will move it a little bit like that, you can see there is a acrylic small pipe inside of this, and it is a part of this acrylic tank, and it also has a thread, so you can remove it if you wish. And from the pump, there is a small part to present it on the screen, but I will try to give you a clue. You can see here is another pipe that goes. You can see this is the pipe, the metal part, thread, and there is a pipe inside of it, and you can see it, and it goes to the water pump, and through this the coolant goes up and to the water block, water block, and then from the water block it goes to the radiator. So it's difficult to present it when it's already filled with the coolant, but yeah, this is something that is working, and you will see this in progress when I will turn it on. And what I did, Michael, already, I figured out how to use a cron to turn off and turn on the LCD, this small LCD screen, this OLED display, I2C OLED display, and I figured it out, and I will also present a separate article about this on my website, how to make it work, because I was using your article and on your website to make it work. I mean, to display the proper information on it. But then someone asked you in the comments, and I already gave an answer, but I don't know is it accepted by you, that my answer how to make it work, because you need to make two scripts and put them into the cron tab, and one runs in my case at 7 a.m. in the morning, and the second is working about at 8 p.m. In the evening, right? So one script turns off the OLED, and actually doesn't turn off, it dims to 0%. So the OLED is working, but it's dimmed, and there is no information displayed on the OLED. And one script is setting it as a 100%, and the second one is setting it as a 0%, so it's not displaying any information on the OLED. And thank that it's black, and at night it doesn't flash in the room. So this is the solution that I was that I wanted to make it work, and I did it. So that's the how to make it work advancement. Yeah, this is the advancement of this project, and I think that we should find out is there a way to make this project better, because all those things, all those stuff that I was testing during a year, I didn't have much time to focus on this. So there was something like, oh, I bought this. Then I had to wait a month when it will arrive. then it arrived, and okay, I will try to this. Okay, I need to put these things together. Okay, working. Then go to the shelf, and I need to take my job, and I have another duty. And after a month or two, something else came, and slowly I was putting all those pieces together to make it work. And now I will be able to prototype finally the CM4 board and CM4 compute module, and I will figure out how to install the operating system, because I don't know already how to do that, but I know that I have already seen that there are tutorials how to make it work. So we'll try to one more time to summarize everything. I will redesign the project a little bit. I will send 3D project separately to SMK 3D. I will send acrylic project to crafters. They will do it for me, and then I will use the methylene chloride to make it work, to glue everything together, to bond all those pieces. And at the end, I will turn on the CM4 board, and I will see is it working correctly. And after that, I will have to think, do I want Proxmox on the CM4 board first, or do I want Kubernetes on this machine? I think that Minikube should be enough, and I think that I can try to do that, or eventually, I can think about it, because I'm not really sure what will be running where, and or eventually I will move the whole operating system, the Home Assistant, from Raspberry Pi to InfoBoard, and then I will use the Kubernetes on the Raspberry Pi. But currently, in this case, I'm not sure it is a logic way, just because I don't know just how to move Home Assistant from one hardware to another one. I have a backup, of course, and I know that it will work, but I just want to try to show you that it is possible to move it enough quickly to write a script and to automate the whole process. And when you have two similar hardwares, even how to move Home Assistant from a Raspberry Pi to CM4 board, and then from CM4 board to a Raspberry Pi, I think that I will try to do this for you. And then, of course, Kubernetes, and I will try to present you how to work with Kubernetes, because Kubernetes is not so easy as it seems, how to work with pods and how to make everything secure. Of course, that maybe I will use one of those two to also present more advanced working with Docker, and that's something worth to think about it. But in the meantime, I will just think at home in my free time what exactly to do with this. So I hope I enjoyed this, and I hope you enjoyed this too. This adventure for me, it was very interesting, and it taught me a lot. Thank you very much, Michael. Thank you very much, crafters. Thank you very much, SMK3D. Thank you a lot, guys. You helped me a lot, and I was able to finally do this. And thanks this, I will proceed, and after a prototype, I will make a final version, and I will present on a separate videos. I will make series about this, because it's a lot of work, and I won't exactly present you how to make all those pieces together, and you will be able to observe that first I have to do this, then the next video will be about something else, and the next video about something else, and I will try to make those videos shorter, 15 minutes, 10-15 minutes long, not more. So thank you very much. Have a nice day and take care. Bye bye.